Okay, last video. So the word problems, which you guys did such a great job with. I'm hoping like just finish strong. So a farmer with 10,000 meters of fencing wants to enclose a rectangular field, then divide it into two plots with a fence parallel to one of its sides. Okay, so we have our diagram here. You can label different things. I like to have, like for this one, I am going to designate this X, and this X, this one's Y, and this one's Y. It doesn't really matter because we're actually going to be finding the dimensions of the rectangular field, so we're going to have to find both anyway. But just for the purposes of this, I'm going to do that. You could have done X, X, Y, Y, Y as well. This one doesn't have the greatest numbers, so things that I know that all of the pieces of fencing, so my X plus X plus X plus Y must add up to 10,000. So 3X plus 2Y is equal to 10,000. And I know the area of my fencing is just going to be X times Y. So I have this X and I have this Y here. So it's just gonna be regular X times Y. So first thing we want to do is we actually want to combine the two pieces of information. So we want to have just one variable. So what I'm going to do is I'm going to, since we're trying to find maximum area, I'm going to replace Y with this Y up here. So I'm going to rewrite this. So I have 3X plus 2Y is equal to 10,000. So I know 2Y is equal to negative 3X plus 10,000. So Y is equal to negative 3/2 X plus 5,000. If you do it the other way, it's a little messy, but you end up basically, it'll be fine. All right, we have the same thing. So what I need to do though is I know that my one side is going to be 3/2 5,000 minus 3/2 my other side. So I'm going to replace this Y with this information right here. So my new equation is going to be the area is equal to, and I still have my X from here, times negative 3/2 X plus 5,000. So my area formula is going to be negative 3/2 X squared plus 5,000 X to start with. Now it says what's the largest area? So we want to maximize our area. Remember that it's a quadratic, okay? And we want to find this point right here. So X is my X value, is one dimension, Y is that. So I'm going to start off by finding my vertex. X is equal to negative B, so negative 5,000 over 2 times negative 3/2. So that ends up being negative 5,000 over negative 3, which is 5,000 thirds, and it is some weird number, which we will worry about in just a little bit. Okay, so that's approximately 1,667.67 or 2/3, doesn't matter. I'm not going to be using that number though. I am going to be using my fraction for substitution because it's more accurate. Now what do I have to substitute? I have to substitute X in to the original equation. So A of 5,000 over 3. So I can find my maximum area because that's the maximum X value. So this are the 1,666 or 1,666. So that's my X value. Okay, and all I have to do is find my Y value. So this is going to be negative 3/2 times 5,000 over 3 squared plus 5,000 times 5,000 divided by 3, which seems like a ridiculous number. So when I multiply all of that out, I end up with the area being equal to 4,166,666.67, blah, 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 blah. And this is going to be, my unit of measure is meters squared, because when I multiply meters and meters, I end up with meters squared. So, the next thing is it says, what are the dimensions of the rectangular field? So I know my x value is 5,000 over 3. We're going to actually convert that back into our decimal. But we take that, our 5,000 over 3, and we substitute it in here, if you will. Or you could substitute it in here. So that's going to be 3 times 5,000 over 3 plus 2y is equal to, so this is b, is equal to 10,000. These threes actually divide out. I have 5,000 plus 2y is equal to what? 10,000. 2y is equal to 5,000. And so y is equal to 2,500. So my dimensions, because depending on how you did it, this value and this value could be flip-flopped. My dimensions are going to be 2,500 meters by 1,666.67 meters. So that's the first one. Next one, we go to our handy-dandy revenue function. It says express the revenue as a function of x, which just means that you do need to know that revenue is equal to price times quantity sold. So I know my revenue, I want it as a function of x, is going to be my price, which is negative 1/10 x plus 150 times x, or my revenue of x, so this is a, is negative 1/10 x squared plus 150 x. B, what's the revenue if 100 units are sold? So all you have to do is you put the number sold. So R of 100 is negative 110 times 100 squared plus 150 times 100, which is equal to 14,000. C, what quantity maximizes revenue? This is where you do your negative b over 2a. In this case, it's going to be negative 150 over 2 times negative 10, which is negative 150 over negative 1/5, which is equal to negative 50 times negative 150, there we go, times 5 over 1, which is equal to, times negative 5 over 1, which is equal to positive 750. D is what quantity? So the quantity that maximizes the value was 750. What's the maximum revenue? So now we find our revenue, which is going to be R of 750, which is equal to which is negative 1/10 times 750 squared plus 150 times 750, which is equal to 56,250. Thank you. Keep figuring that out. Okay. E, it's asking for the price. My price is up here. So my price is going to be negative 1/10 times my maximum x value, which is 750, plus 150, which is equal to $75. Okay, number 14. It says construct a scatter plot in your graphing calculator. Use it to find the function that best fits the models. That models the relationship between expenditures and revenues. Now you can do, if you don't have a calculator at home, you can go to get the Calc 8 app, or you can type it into your computer, and you should or calculate A4, sorry, calculate A4. And you can find, actually, there's a whole bunch of emulators out there for you guys to use. So there's a whole bunch of different things. How do you do this in the graphing calculator? Let's just hope that, there we go. So in your graphing calculator, if there is something already, so you go to Stat, you go to Edit, and if there are values in your table already, you go up to the top, press Clear. Do not press Delete and press Enter. Then you press Clear and press Enter. Don't press Delete because it'll delete the list. And you put your values in 15, 20, 25, 30, 35. Okay, 30, 35, 40, 45, 50, 55, 65, 70, 75. Okay, we go to the other list, 22.3. Oh, you know what? This is the wrong one. Sorry, guys, this is the wrong list. 2022. I have to go back up and clear it. Sorry. Clear. There we go. All right. So, just looking at the wrong problem. 20, 22, 25, 27, 28, 29, 31. And then this one is 20, 22, 25. Oh, I have two 25s. You can insert, you can press second insert and it will insert a value. So we have 6101. I know you guys are here for me just entering data. Letting Masali get to the point. You guys can fast forward if you want. 6350, 6378. Make sure to check your values. 6453, 6423. 6360 and 6321. All right. As soon as you get all of that in, you can do stuff like if you wanted to, you could plot your data. You just need to make sure your window, like my window here, should be my X minimum would be about 20. My X maximum would be 32, nope, actually scale. Nope. Okay, let's see, window. If you wanted to see, this would be 31. I'm just showing you unnecessary things right now. My lowest value is about 22.3. So I'm gonna do 22, and my highest value is around 30, so I'm gonna rate 31. If you wanted to graph it, okay, this never works when I try it anyway. All right, so you guys could skip all over that part. All right, so when you're trying to find regression, you go to number 5, quadratic regression, list 1, list 2, frequency list, all of that. And it looks like I have something goofed up anyway. So again, check your list, be like Santa, checking his list, checking it twice, 6350, 6378, 6453, 6423, 6360, 6231. There we go. Because this will mess everything up. So 6231, enter. Okay, so just make sure that when you are doing all of this, that you make sure your data is okay. There we go. So I have my -7. So I'm going to say when you do your graphs, This is going to be, so A is going to be y is equal to negative 7.7596 x squared, because that's your A value, plus 411.8750 x plus 942.7211. So there's your equation. And so here's the function that best models the relationship. It's a G function to find the optimal level of advertising to produce the most revenue, which is going to be the x value of your vertex. So B is going to be your negative 411.8750 over 2 times negative 7.7596, which is approximately 26.5397. Now that's the number that I'm going to use to put in the calculator is an extended decimal, but I would just say that this is going to probably be around, it looks like everything's rounded the whole number, around 27. C, I plug this in, so negative 7.7596 times x, which is 26.5397 squared, plus 411.8750 times 26.5397, or 26.5397, plus 942.7211. And when I put all that jazz in the calculator, I end up with 6,408. And then I'm going to round to the nearest hundredth, 0.24, because we are talking about money. All right, so that's A, B, and C for that one. That one's pretty easy. I apologize for the sidebar. Okay, number 15, a horizontal bridge in the shape of a parabolic arch. Given the information shown in the figure, what's the height of the arch 2 feet from the shore? So when you look at this here, see, this is so nice in color. If you put your coordinate plane here, I look at this, I know the y value of my vertex is going to be 10. I know this has to be 10, and that has to be 10, those two distances, because I know across is 20. So I know that my bare minimum, I know that my equation is going to be y equals a times x minus 10 squared plus 10. I don't know what a is. I do know that the coordinates of this point are 0, 0, and this point is 20, 0. So I'm going to put the 0, 0 in, so I know that when x is 0, y is 0. So this is going to be 0 is equal to 100a plus 10. Sorry, this should be a 0. Negative 10 is equal to 100a. A is equal to negative 1/10. You can use a decimal as well. So the equation of this little arch right here, y is going to be equal to negative 1/10 times x minus 10 squared plus 10, if you were thinking about it that way. It says the arch has to be 2 feet from the shore. So we have a couple options of where we can do this. If we're talking about this 2 feet here, then from here to here, you could plug in 18. But also, this is also 2 feet from the shore, so you could plug into here. So it doesn't really matter too much. So I'm going to put in y equals negative 1/10 times 2 minus 10 squared plus 10. And so you end up with y is approximately 3.6 feet. Okay, and then our last question is a kicker in football punts the ball down the field during a game. The height, y, and feet of the ball is given by this. How high is the ball when it is punted? So I like to do a little graph because I need the visual. So you know it's kicked off the ground and goes and then hits the ground. So my first thing is it off the ground to start with? And this is actually where my x value is going to be equal to 0 here. So for A, this is going to be y is equal to negative 16 over 2025 times 0 squared plus 9/5 times 0 plus 1.5. And so this is equal to 1.5 feet. for B, what's the maximum height? So we're talking about this point again. Of course, our vertex, x is equal to negative b. So that's going to be negative 9/5 over 2 times negative 16 over 20/25, which is equal to around 113.9. So when you put all that in, it's about 113.90625. I like to use as much decimal as possible. For my answer, I'd say it's 113.9, but that's only part of it. So that's actually the x value. That's the horizontal distance, or that's a horizontal distance. But it was asking for the maximum height, so you actually have to plug this in to the original problem. So this is negative 16 over 20/25 times 113.9 squared plus 9/5 times 113.9 plus 1.5, and so my actual answer is approximately 104.02 feet. All right, let's go to C. So C, it says, how long is the punt? So we want to know when the punt hits the ground. So we put 0 in for y. So this is 0 is equal to 16 over 20/25 negative x squared plus 9/5 x plus 1.5. And so I have a quadratic. I need to use the quadratic formula. So I have x is equal to negative 9/5 plus or minus the square root of 9/5 squared minus 4 times negative 16 over 20/25. C times 1.5. There we go. All over 2 times negative 16 over 20/25, which is a mouthful. When you throw all that in the calculator, just be really careful. Please use that fraction button because it's really easy to mess up. I end up with 228.64 feet. And you put it in twice. You put it once for the positive and once for the negative. One of the answers is going to be negative, so that's not possible. So you only go with the positive answer, which would be the x value right here. So it's about 228.70. All right. This part is the bonus. Is if you want to make a field goal, this right here is 10 feet. And so the question is, how close must the punter be to the goal to make a field goal if he kicks it using the model above? So actually, we do have two options because you also have this guy here. So for D, that's actually when my equation is equal to 0, or is equal to 10. So I'd subtract 10 first, and I'm going to do the same thing that I did with C. So 0 is equal to negative 16 over 20/25 x squared plus 9/5 x minus 8.5. That x should be up here. Sorry about that. And so I do the quadratic formula again. So x is equal to negative 9/5 plus or minus the square root of 9/5 squared minus 4 times negative 16 over 20/25 times negative 8.5 all over 2 times A, which is negative 16 over 20/25. All right. It's like punishing getting through this. All right. So when you put all of that in the calculator, you end up with a couple of answers. Remember to use your fraction button, so alpha or the other fraction button that some of you have. So you know you're going to do negative 9/5. And you're going to pick one. You can pick plus or minus. I'm going to do plus. The square root. And then 9/5 squared minus 4 times negative 16 over 20/25, and then C is times 8.5 times negative 8.5 all over there we go, 2 times, and then this is going to be negative 16 over 20/25, and you press enter, and one of the values I get is 4.8. Okay, so right here would be 4.8. Okay, so if you're 4.8 meters away, you would make it, and then we go up, press enter, you don't have to type all of that in, we just change our plus. Okay, and so our second answer is 223.0 or 222.99. Or 4.8, or anywhere between. Okay, so that's about it for the review. Hopefully the video was helpful, and I'm sure you guys will do great.